Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the topic from Sequential Logic Circuits. Other name is Sequential Circuits. In this unit the first topic is the introduction of the Sequential Logic Circuits. The subject is Digital Electronics. In this class we will be seeing the definition of a sequential logic circuit, the block diagram of a sequential logic circuit and the comparison between sequential and combinational logic circuits. So, as you know, the digital logic circuits, what are the basic building blocks of a digital logic circuits? Gates, that is AND gate, OR gate, NOT gate. Universal gates are NAND and NOR, XOR, XNOR and all and so on. So, NAND and NOR are universal gates. So, the building blocks are logic gates. Based on the logic gates, we are able to design a digital logic circuit to perform a particular application. So, the digital logic circuits are broadly classified into two categories: combinational logic circuits and sequential logic circuits. In our previous classes, we have covered combinational logic circuits. Few examples of combinational logic circuits are half adder, full adder, half subtractor, full subtractor, parallel adder, parallel subtractor, binary multiplier, code converters, multiplexers, demultiplexer, encoder, decoders and so on. We have seen combinational logic circuits. Now we are going to start sequential logic circuits. Let us start with the definition of a sequential logic circuit. In sequential logic circuit, the output variables depends not only on the present input variables, but they also depend upon past history of the input variables. Okay. So, it will be more clear if you look at this block diagram. So, this is the block diagram of a sequential logic circuit. The other name of sequential circuit is FSM, finite state machine. In a combinational circuit, what you are having? Circuit having input and output. But when you are taking a part of output and storing it in a memory element and then giving it back to the combinational logic circuit, it becomes a sequential logic circuit. So, what is addition in sequential logic circuit? The memory element. So, sequential logic circuit will have a memory element. Why we need to have a memory element? To know what is a past history, what is a past value. Okay. So, the past history is provided by the feedback path. This is known as feedback path. When the part of output is fed back to the input, it is known as a feedback path. So, in the feedback path, we are placing a memory element which is known as sequential component. The past history is provided by the feedback from the output back to the input. So, what is the definition of a sequential logic circuit? In sequential logic circuit, the output not only depends on the present input variable, but they also depend on the past history of these input variables. Okay. So, the output not only depends on the present input variable, but also on the past history of this input variables. Now, let us say the comparison between combinational and sequential circuits. First point under combinational logic circuit. In combinational logic circuit, the output variables are at all times dependent on the combination of the input variables. In a combinational circuit, whatever is the output is depending on the combination of the input variables here. Okay. In sequential circuit, the output variables depend not only on the present, but also on the past history of these input variables. So, this is a combinational circuit where the output is dependent on the combination of the input variables, and this one is a sequential circuit where the output is dependent on the present input as well as on the past history of the input variables. Second point under combinational logic circuit is memory unit is not required, whereas in sequential memory unit is required to store the past history of the input variables in the sequential circuit. The combinational logic circuits are easy to design and are faster because there is no feedback path. It is easy to design and it comparatively the output is also faster. Sequential logic circuits are comparatively harder to design, comparatively, because in combinational we do not have a feedback, in sequential we are having a feedback because the output depends on the present input as well as the past history of the input variables. It is harder to design and it is slower also compared to combinational logic circuit. Example of combinational logic circuits: a parallel adder is a combinational logic circuit, serial adder is a sequential logic circuit. So, these are the 4 important points to be remembered for combinational and sequential logic circuits. The basic thing is that block diagram. In combinational logic circuit, the output is depending on the combination of the input variables, whereas in a sequential logic circuit, the output variable depends on the present input variables, but also on the past history of this input variables. I hope you have understood the introduction class of sequential logic circuits. Thank you. Good luck, students.